Okay, so I know I've talked some about due dates already, but these due dates mainly go for dual credit. Just a reminder, we have assignment 2.3 due tonight in Blackboard, 2.4, which I got on Friday. Thursday is due tonight. The one I got Friday is due Wednesday, and then the one I passed out today is due on Friday. Now, with that being said, the one I gave y'all today, you could probably do well over half of this after today's notes. There's 10 questions on this assignment. One, I'm not for sure. Two. There's only two that you'd have to wait till tomorrow. So you could do 8 of the 10 questions tonight, or today, I should say. But chances are most of you are probably worried about 2.3 right now. So we'll get through the notes, and then we'll have about 15 to 20 minutes to work. Okay, now we're good. So, at the end of the day, Friday, we looked at finding the inner quartile range, which meant we had to find the first quartile, the median, the third quartile. And what that was doing was setting it up so that way today we can look at how to do box plots. Now, chances are you've already heard of box plots. Another name for them are box and whisker plots. So you may have already heard about them. Okay, so hopefully you took good notes on Friday because we'll kind of need one of the examples for today. So, yes.
I'm sorry. The thing you just gave us is up due Friday?
Due Friday.
All right.
Now that one, I haven't put in the Blackboard yet, but
Yes,
it should be done tonight.
all right, sounds good.
I have put 2.4, which is the one due Wednesday, in the Blackboard.
All right.
So. Okay, so a box plot is a picture that conveys information about the most important features of the data set, namely the center, spread, skew, and presence of outliers. So even on the box plot, you'd still be able to, as we called it earlier this semester, cuss the graph. So what are some advantages of box plots? Well, for one, they're easy to draw. They conveniently handle outliers. We can clearly see what's an outlier and what's not. Their construction is not subjective like histograms. We're not making classes or anything like that. We're basing it on our quartiles and then the max and the min. So there's no like, oh, well, if I make my classes wider, I can make the data look like this. Or if I make them narrower, then I can make the data look like that. None of that's going on. It's not subjective. And we tend to use them with medium or large size data sets, where n is greater than or equal to 10. Those small ones, they tend to distort the data. You don't want to use it if you have less than 10 data points. And they're useful for doing comparative displays, as we'll see throughout today. So when do we use them? When you have univariate numerical data, but make sure the data set is not less than 10. If n is less than 10, you don't want to use these. We need n to be greater than or equal to 10 in order to use. So the first one we're going to look at is a skeleton box plot. It's just your most simple, basic box plot. Then we'll build on it. So first thing we need to do when we get ready to build any kind of box plot is do our 5-number summary. So we need to know the smallest observation, which we just call it low. The first quartile, the median, the third quartile, and the largest observation, which I just call high. So we need to know our quartiles and then low and high. Once you know those, you can draw your horizontal or vertical scale. It doesn't matter which way. If you want to do a horizontal box plot, that works, or a vertical one works as well. Then you make your rectangle. So the rectangle is made from the lower quartile Q1 and the upper quartile Q3. Then inside the rectangle, we'll mark where our median is. So we'll draw a line at the median. And in case you didn't, I know we haven't had a blank yet, but in case you haven't noticed, there's our first blank, median. And then we draw lines from the lower quartile to the smallest observation, and from the upper quartile to the largest. That's where we get the term whiskers from. It looks like a box with whiskers. And then to describe, we cuss the graph. We talk about the center, the spread, the shape, and if there's any unusual features like outliers. And we're actually going to learn today how to classify outliers as being mild or extreme. But you don't do that on a skeleton box plot. You need to go back. Get that written down, and then we'll get into our first example. And at least on all the ones where we have to draw a box plot, I'm doing those with y'all. So it's not like I'll be click, 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 you got it down. I'm going to work them out with y'all. Okay, everyone got the info on this slide written. How to make them. Okay, so if you remember on Friday, we did an example that talked about the percentage of the population with bachelor's degrees. in the 50 states and DC. So what they want us to do is take that data and make a box plot with it. Okay, so that's what this first example is. So let's think back to what we did on Friday and make note of our quartiles. And you can, if you want to turn back to your notes from Friday, you can. Let's go to what we call our 5-number summary here. So what's the lowest data point here? What's the smallest? Okay. What was our first quartile that we found on Friday? And if you don't remember where it was, it's on page, this example is on the bottom of page 11. We found the first quartile, median, and the third. Well, let's start from scratch then. First, let's find the median. So we know, I'll show you a little trick to find the median real quick. We know there's 51 data points, right? So if I take that and I go down to 50, what's 50 divided by 2? 25. That means the 26th point is the one in the middle. So there's 10 per row here. So 10, 20. There's the median. That's our 26th data point. So now, the top half and the bottom half each have 25 data points. So take 25, go down 1 to 24. What's 24 divided by 2? 12. Add 1, you get 13. So count 13 from the beginning. That's Q1. So Q1 is 24. The median is 26. Now we need to get Q3. Well, we can again count 13 from the end, and that'll be Q3. 11, 12, 13. So Q3 is 30. What's our high value? What's our highest data point? 47. This is what we call a 5-number summary. Okay, so at this point, we have our 5-number summary. We can draw our box plot. We're going to, for now, just do a horizontal one. So let's draw our axis in there. Now, what do you think we should count by? 5? Okay. Where should I start? What? 15. Good. I'll start down here at 15, and then we'll count by 5s. 15, 20, 25, 30, 35, 40, 45, 50. Okay, so there's our axis. Now, what do these numbers represent? Are they ages? Or are they heights? The percentage of the population. So we don't have to write that whole thing down here. We can just say percentages. And I included this on the review for dual credit. But on the test, you'll need to know how to get this 5-number summary. And you'll also need to know how to draw a box plot. Again, that's on the review, though. That's in Blackboard.
Mr. Schultz,
Yes.
are you gonna give us like a paper review as well, or is that the review?
Depends on how we are on copies, honestly. I'll have to look at our copy numbers.
Yes, sir.
I mean, it probably won't be, if I do give it to y'all, I mean, I don't know how useful it will be, because it's just, know this vocab, do these things, and that's all it says. So there's no actual workout problems or anything on it.
Gotcha.
Which sounds kind of harsh, but that's actually how they do reviews in college. So what you would do at that point is look through like your homeworks and the notes and like, okay, where did we do this? Where did we build a box plot? Oh, we did that on page 13 of the chapter 4 notes. Okay, make sure I know how to do this. So maybe you circle it, highlight it, something like that.
Yes, sir.
Okay, so let's make our box. So for our box, we go from Q1 to Q3. So that means I'm going to start, see if I can actually draw a rectangle here. Yep, that's what I want. I'm going to start at 24 and draw a box all the way to 30. It's actually a little bit further, but hopefully y'all get the idea. 24 to 30. And then our median is at 26. So at 26, I need to draw a line like that. So there's our box with the median. Now, what's my lowest value? 17. So from this lowest side, I'll need to draw a line, a whisker, out to get to 17. And I tend to, you don't have to do this, but I tend to like to put a little bar there that shows, hey, I stopped here. I stopped there. And then on the high side, I have to draw one all the way out to 47. Here we go. Okay, so that's all there is to a box plot. It's also good practice to label what you're looking at here. So what are all these lines? What do they represent? Well, let's see. This one right here is our low value. That's what? 17. That line is our Q1 value. That's at 24. This line is our median, but remember, what's another way to say median? In terms of quartiles? Quartile 2, which is 26. And then this one is quartile 3, up here at 30. And last but not least, we have our high, that's at 47. Okay, questions on this example? Okay, then let's look at the next part. So these are all great and all, but then we can't really see what's truly an outlier. So let's try to figure out how we can determine what's an outlier and what's not an outlier. Okay, we drew it. So an observation is considered an outlier if it is more than 1.5 IQR away from the closest end of the box. Which means if it's the lower part, it'd be the lower quartile minus 1.5 IQR, or the upper quartile plus 1.5 IQR. If it's outside those ranges, then it's an outlier. It's extreme if it's more than 3 IQRs outside the box. If it's exactly 3 IQR, I would say that'd probably still be mild. This says, going off of the definition, more than 3 IQR is considered. And honestly, I don't think as far as like AP exam goes and testing here go, I don't think we'd do that too. Then that's a judgment call, basically. So, okay. So a modified box plot represents the mild outliers by a shaded circle, so we fill the circle in, and extreme outliers are open circles. And the whiskers only extend to the either at the lowest end, if your lowest data point's not an outlier, or to that 1.5 IQR cutoff. They won't stretch all the way out. So let's look back at our degrees example. Now we're going to take the same data, but this time turn it into a modified box plot. Okay, so just to remind us of what all our values were, what was our low value? 17. What was Q1? 24. What was our median? 26. Q3? 30. And then, see if I can squeeze high in here. What was our high value? 47. Okay, so we need to get our interquartile range. So remember, IQR is found by doing Q3 minus Q1, which gives you just 6. Okay, what I recommend is before doing like any of the box plot or any of that, let's go on and figure out what is Q1 minus 3 IQRs. What's that equal to? It's equal to 6. Okay, Q1 minus 1.5 IQRs. So let's see, 1.5 times 6 is 9. 24 minus 9, 15. Then we have Q3 plus 1.5 IQR. Q3 is 30, so 30 plus 9 is 39. And then Q3 plus 3 IQR, which gives us, 3 times 6 is 18, 48. Now, if we're within this range, if we're within that range, we would say that this is normal. So no, it's not an outlier. If it's in that range, it's not an outlier. If we're in that range, this is a mild outlier. Same with that one. That range is mild. Now, if we're beyond those, that's what would be extreme. Okay, so let's draw our box plot with this information. So we're going to do the same scale that we decided on earlier. We're going to count by fives. 15, 20, 25, 30, 35, 40, 25. Okay, so let's draw our rectangle now. So we've got to start at 24 and go until we get to 30. I don't like that one. Now, where is our median? 26. So we need to draw a line at 26. No, that's too far down. There we go. Okay, so what we need to look at here is, since 15 is considered normal, does our data actually reach all the way to 15, or does it stop before 15? It stops at 17. So we'll draw our whisker all the way out to 17, but then stop. We won't go all the way to 15. Okay, now on the upper end, do we go to 39? Do we go past 39, or do we stop before? On our data, what's our data be? Well, we've got a 47 over here, so we go past the 39, but we won't draw a whisker past the 39. We have to stop our whisker at 39. And I'll fix that. It's bothering me.
What's the high? Is it short?
The high is 48. Okay, let me doctor up our plot because it's the lack of preciseness is bothering me. There we go. Okay, so there's the modified box plot, but now we still have an outlier. This 47, what kind of outlier is it? Is it mild or extreme? So is it between our 39 and 48 range?
Mm-hmm.
Yes, so this is mild. So what kind of circle would I put at 47? A shaded circle.
It's short.
Yes.
So like, why is it? Why did the whisker stop at 40 again? It's
But-
high.
So while it should actually have stopped at 39, what that shows is that's our normal range there. They're not outliers. Anything beyond the whiskers are considered outliers.
Okay. So like, what is the low right there? Like, wouldn't it be 15?
The low
Yeah.
is 17.
All right.
It's just that 15 is saying that we could go all the way down to 15 without it being an outlier.
Okay.
But our data doesn't go that low, so we don't have to worry about that. Okay, questions on this one? Okay, let's go back to our PowerPoint. So they're just doing everything we did. Oh, back up. Okay, so if we describe the data, describe the box plot. So this is where we got to cuss the graph. We can say that the distribution of the percent of the population with a bachelor's degree or higher for the U.S. and D.C. is skewed right with an outlier of 47%. So we mentioned our outlier. Median is at 29%, 26, I can't read. 26%, and the range is at 30%. So we talked about the center, talked about unusual observations, we talked about the shape, and then we're getting that last S. Spread. There you go. Yes. The spread. So we still were able to cuss the graph. Okay. Now, you may be wondering, well, how can he tell that it was skewed right just by looking at the box plot? Let's talk about skewness on box plots for a second. So, ignore for a minute the histograms down here. Ignore these on the next page. Just focus on the box plots. If we look at the box plots, they all pretty much look identical for the most part. But now if we look at the histograms are completely different. I mean, first one is bimodal, second one's uniform, and then we have another bimodal. So histograms are totally different, but yet the box plots look the same. So let me ask you this. Based on box plots, can we figure out what the mode of the data is? No. Nope, we can't. There's only one instance where you could, and that would be quantile 1, 2, and 3 are all the same number. Because then that means half the data would have to be that number. But if low and high are also that number, then it'd be a uniform distribution. There wouldn't be a mode. So in general, no, you can't. It doesn't really tell us much. But what it does tell us is skewness. So if we look at this first graph on the right side, notice that the arrows are about the same size. So we start at the median and go each direction. They're about the same size. So the range of the lower half and the range of the upper half are approximately equal. So we can say that the distribution is approximately symmetric. So if we look at the next one, which arrow is longer, the right or the left?
Right.
The right is the longest, so we say this is skewed right. So if we go back for a second to that example that we just did, the one we just did here, let's see if we can actually justify why this is skewed right. So what we would need to do is start at the median and go in each direction.
Are we still on this last one we just did?
I briefly talked about skewness and then we went back to it.
Okay, I got you. I was making sure I missed
Yep. Okay, so that's from the median to the right side. Then draw an arrow from the median to the left. Which arrow is longer?
the right one.
The right one. That's why we can conclude that this is skewed right.
I got you.
That's how we were able to say that when we tested the graph earlier. Skewed right. We don't know the exact shape if we did a histogram, as if we did a histogram, but we can still say how it's skewed. Because the right arrow is way longer. Okay, so let's look at the next thing. I'm going to give y'all a chance to kind of wake up, talk to your neighbor about this next example. Looks like y'all are falling asleep on me.
Is this supposed to rain today?
I think there's a chance of rain pretty much all the way through Thursday, I believe.
Yeah, Apple's not saying we get anything for it now. We're gonna have a cloudy day.
It's gonna feel good at practice.
I'm so excited.
Okay, so on this data set, I want y'all to compare salary data for the 5 teams. So I want you to discuss similarities and differences in these box plots. So I'm going to give y'all about 4 to 5 minutes. You can do it on your own. You can talk with your neighbor, but try to find some similarities and differences in these box plots.
Mr. Schultz,
Yes.
if we have a little bit of time, like at the end, like if we have like 10 minutes left after notes, would it be alright if I ask you a few questions about the homework?
Absolutely.
Alright, 'cause I did it and I missed like 3 of them, and I was confused. You done this one?
So some things to look at your minimums, look at your medians, outliers, ranges. You can on chat.
Mr. Schultz, whenever you did it, whenever you did it yesterday, like earlier on the modified box plot, it was like 2 minus 3 IQR, and then like 1 minus 1.5 IQR. Is it always gonna be like the 3 and the 1.5? Okay, so that's how you find it.
Yeah.
Thank you. Mr. Schultz,
Yes.
could you actually like come in on your own from over there?
I can go over there.
Thank you. The modified box plots are just kind of confusing, like, I was just gonna ask, like, what the difference was between, like, how you got these numbers for these?
What do you mean, like these numbers?
Yeah, like, how did you make the box plot for this?
Okay, so what we did, the box itself is the same. What we have to use, this helps us determine the outliers. So what we will do is, like I said, the box will be the same. But then when we go to draw on whiskers, we only want to draw whiskers up to these points if we need. Right here, we could draw a whisker all the way to 15, but we didn't need to. We did 17, so we can draw 17. Here, we could have drawn whisker all the way to 39. We needed to because we have a point at.
So those, I thought you had to go to 40 days, so.
So the whiskers only go in the normal range.
Okay. I got you.
And then once you get outside normal, that's when you start going the dots or the outliers.
So like, on the normal one, it would look like that, though,
Yes,
because you wouldn't have done that little calculations right there.
that's right.
All right, okay, I see what you mean. I was curious, because I didn't understand like how these like changed up, how the data points go.
Yeah.
Okay, okay. Thank you. Judy, can you explain?
Okay, so what are some differences and similarities that y'all noticed on these 5 box plots?
I saw that like, me and Lisa saw that like a lot of them, or like almost all of them were all skewed right.
They're all skewed right? Okay.
Minus maybe the Grizzlies. Yeah, aside from that,
Yep.
they're all skewed right.
Yep, that's a good observation. What else?
The Q1 value for almost all of them, really all of them is really within the same range for about less than 2,500,000.
Yep, most of the Q1s pretty much line up. That and the minimums tend to almost line up, except for the Grizzlies. Speaking of Grizzlies, what can we say statistically related about them? We're not going to like bash them basketball related, but according to this chart, what can we say about this data for them? They have a mild outlier, yeah. Who else has a mild outlier? The Lakers. What about most of their pay? Does it tend to be the same, or does it tend to be lower than the rest of the teams?
It's lower and more.
That's right, it's lower and closer together. The range isn't quite as large. So, which means most of the Grizzlies players make less than the rest of the league, because their median is really close to the lower quartiles on all the rest. So on the Grizzlies,
Oh, just on the Grizzlies?
yeah.
Okay, I thought you meant.
If we look at their median right here, it's pretty much on the lower end of almost all of these.
Yeah.
So half of their players get paid less than the majority of the league, or at least the 5 teams we're comparing.
It's crazy that the majority of the players in the Nuggets get over $3 million.
Yep. We were talking about this last period. Anyone have an idea of who this outlier on the Lakers is for that date range?
LeBron.
Is it LeBron?
It's gotta be.
It has to be. I don't really follow basketball much. I'm like, the only one that came to mind is Michael Jordan. I'm like, he's been retired how long now?
Yeah, that's gotta be LeBron.
Gotcha. Okay. Come on. Okay, another modified box plot example. So we have some data, looks like their ages, for 79 students. They want us to create a modified box plot with this data. So let's do it. The one thing we need to do is get our 5-number summary. So what's our low value here, since they already ordered it for us? 17. That's our low. Okay.
That was my bad, Mr. Schultz. It was actually Kobe Bryant. Present case.
Kobe Bryant?
Yes, sir.
Gotcha. Q1, Q2, which is our median, Q3, and then our high. What's our high value? 47. Okay, so let's find the median here. We can use that little trick, if that's what you want to call it, that I told y'all about. There's 79 data points. So subtract 1 from that, you get 78. It's the 40th point, that's right. So the 40th point is our median. What would Q1 be? Which point would Q1 be? Because now we have 39 in the top, in the lower half of our data. So we would want to look at the 20th data point, which is 19. And then for the upper end, we want to look again at the 20th data point of the upper half of the data, which is 22. So the way they laid this data out for us was really nice. They put everything on the ends.
What's the Q3, 22?
22, yes.
Gotcha. 22.
Yeah. Well, the 21s also. Okay, so let's figure out our ranges that we're dealing with here. So if we do Q1 minus 3 times our IQR. Oh, we didn't find IQR. Hang on. What's IQR? Remember that Q3 minus Q1, which is 3. That's IQR. Okay, so Q1 minus 3 IQR would give us what? That would be 19 minus 3 times 3. 10, yep. Then we do Q1 minus 1.5 IQR. What would that give us? It will be, yes. 14.5. Then we need to do Q3 plus 1.5 IQR. That one will also be a decimal. 26.5. And then Q3 plus 3 IQR. $31. So again, if they're in this range, they're considered normal. So on the low end, we're all normal on the low end because we stop at 17, which is well within our normal range. So let's look on the high end. What number do our outliers start at on the high end? What's that?
Like, when we need to start.
So once we get outside this 26.5, then we start getting into outlier range. So where do we get larger than 26.5? 28. So if we're between 26.5 and 31, we call those mild outliers. So do we have any other mild outliers? 28, 28, and 30. These are mild. If they're bigger than 31, they're extreme. So that means these other points out here are all extreme.
And there's no like upper or lower mild ones because there's like, because it starts at 17.
Correct.
Okay.
That's correct. So now let's draw our axis. We're going to do a horizontal one first, and then we'll go back and talk about what a vertical one would look like. So what would be a good starting point for this one? You want to start at 5? I think we can go over starting at 15 because there's a 17 right there.
Oh, I'll start my energy.
And yes, we can count by 5s. So 15, 20, 25, 30, 35, 40, 45, 50. And it looks like we're dealing with what? What do these numbers represent? Are they percents? Are they heights? Are they weights? What are they?
Ages.
They're ages. We're going to write that down here. Okay, so now we need to draw our box. So our box goes from 19 to 22. Let's say tiny box. And our median is at 21. Okay, now for our whiskers. So for the whiskers, on the low end, do I go all the way to 14.5 or do I stop before then? Because I can draw whiskers all the way to 14.5, but do I need to?
You go to 17.
I just go to 17 because that's where I stop. So I don't even go very far out before I have to stop. What about the upper end? So can I go all the way to the end of the data set or do I have to stop before then?
You don't think this will be 26.5?
26.5 is where I have to stop. Okay, then I have my mild outliers. The mild ones, what kind of circle are they? Shaded. So I'm going to put a dot at 28 and a dot at 30. You don't have to put 2 dots and stack them at 28. Just one's enough. We're just marking location here. So location at 28, location at 30. Now, what about the extreme outliers? What kind of dots are they? They're open. So I need one at 37. I need one at 38. One at 44. And then another at 47. So now you can look at this box plot and say, okay, I'm dealing with at least 6 outliers. Without even seeing the data set, you know you're dealing with at least 6 outliers. Those last 4 must be more extreme because they look different. Now, to save time, I'm not going to draw it, but I do want us to look at a vertical box plot. So we're back to the PowerPoint here. Okay, we did all that. So that's how our box plot looks horizontally. Now let's flip it and make it vertical. Okay, yes, I know. Smaller value, that is an outlier, largest value. Okay. That's how it would look vertically.
So it's the same thing, just up.
It's the same thing, just turned upwards. So if you want to draw that real quick, you can. But it's the same exact box plot, we're just drawing it vertically instead of horizontally. Let's see, so I'm trying to draw it. So. Okay, last example in your notes, they have a brief one afterwards, but as far as notes go, this is the last example. So if we've already saw one example of comparative box plots, and here's another. By putting the box plots in 2 separate groups or subgroups, we can compare their distributional behaviors. So on this display, I want y'all to compare some similarities and differences. What are some things you notice that are similar? What are some differences? Or you what?
Are we supposed to say them right now?
You can, yeah.
Males has more outliers than females.
Now with more outliers, okay. What about the distribution shapes? Are they similar? Are they different?
Male looks like a skewed nut, and female looks like a skewed nut. That's the thing.
Let's see. To me, male definitely looks skewed right, yes. But female, this arrow still looks like it would be longer to the right than to the left.
Because like from what I see, like the left tail looks longer on females to me.
Well, you gotta remember, we have to look from the median all the way out to the outliers.
Yeah.
So the tail may be longer. Oh, you're saying the actual
Yeah, I did the thing, and it looks longer to me.
looks longer?
That's just me.
Could be. Honestly, they're probably pretty close.
Yeah, they're pretty dang
Yeah, they're pretty close. So shape-wise, they're about the same, but then as a whole, what can we say about female weights versus male weights?
close. They're lower.
They're about, they're lower. About 20 pounds as a whole lower. So that's what that says. The distribution pattern of female and male student weights have similar shapes, although females are roughly 20 pounds lighter as a group.
Are we gonna have to write stuff like that on the test?
Y'all won't.
Alright,
I know for sure y'all won't.
awesome.
AP, probably so.
Alright. Sorry.
Okay, questions on this one? So the next slide's not in your notes. They just want us to kind of talk about the presence of outliers and what it does to the mean. So if we look at these two box plots, they're doing age and then gender. For female, the average age is completely outside the third quartile line. It's getting close to outlier range. But that's because look how many large outliers females have. Compared to males, the average is pretty darn close to the median, but it only has one outlier. So this is another way you can see the impact of outliers on the average. Remember, outliers will pull the average in the direction of the outlier. So with that, we're done. That was 4.3.
Mr. Shulman, ask you a question now?
Sure. Let me stop the recording right quick.